Hi everyone, thank you for joining on this talk on bloop. Today I'm going to present what is bloop. So first, who am I? My name is Martin Duhem. I'm an engineer at the Scala Center. I've been there for just a bit more than a year now. I'm particularly interested in tooling and compilers. And previously I've been working first on some macro stuff. I've been moving with SBT and Zing, then I moved to Scala Native, and now I'm mostly working with Dotty and Bloop, of course. All right, so today first I will explain what Bloop is and what it's not. Then we'll see why I personally think that Bloop is exciting and what I think it can bring for Scala developers. Also, why it's exciting for tooling authors that are gathered here today, and what can we do now that we have Bloop that we could not do before? And also we'll see what to look for in Bloop and what is the road for Bloop 1.0 final. So, what is Bloop? First, I just want to make it clear what Bloop is not. I think that maybe it has been unclear that for some people that have thought that maybe Bloop was a build tool. It's definitely not a build tool. Bloop is not going to do dependency resolution for you. It's not going to generate sources. It's not going to make a fat jar with your application and deploy it to a production service. None of that is any of the constants of Bloop. Bloop is much simpler than that. The idea is to do just one thing and do it well, instead of trying to do everything, just like John said this morning. So, yeah, I'm calling John. So why did we invest in Bloop? We made the observation that migrating to new tools is something that is really difficult, because first you have to learn those tools, you have to get used to them, and of course the actual migration takes a lot of time and you have to rewrite all your logic and so on and so forth. So if I can go to our website, the idea was to we've created Bloop to support all the build tools that exist and be able to leverage your existing build configuration. So the takeout from that is that we are better off just integrating with tools that already exist and for which you have configuration, but that doesn't mean that we cannot still bring improvement to toolings for Scala developers. All right, so now what is actually Bloop? Bloop is two things. First, it's a compile and test server. So what is a compile and test server? It is a server, obviously, that's going to compile your project and run the test for you. And being a server, it means that Bloop one server is going to communicate with several clients. And that means that also you're going to share things between clients, which allow you to be faster for some reasons that we'll discover soon. And also you want to share the state of your projects between several clients, so that if two clients has to compile the same project, you will not do the same work twice if you don't need to. And also you have to support concurrent commands coming in and so on. So being a compile test server, Bloop is able, thanks to sharing, to give you faster compilation. So as you probably know, the JIT on the JVM, whenever you run code, it's going to optimize it and so that it becomes faster. So the more you compile with Bloop, the faster it's going to get, because you're going to reuse the compilers that you already used. So I have here a few examples of compilation runs. So you can see with Bloop that the first takes almost 9 seconds, and then the later one are much faster thanks to the JIT. This is examples of how long it takes to compile some large and medium projects with Bloop versus SBT. And we can see that, for instance, for gradient frontend, we have 28% improvement on compilation speed, which is great, I think. The same for Spark, and then for SBT it's about 25%. So it shows that doing the reuse that we have is actually bringing some performance improvements. Yes? This is for the shell. Where was I? Okay, so we have performance improvement thanks to the reuse of compilers and thanks to the simple structure of Bloop, which was to shave off some things. Also, being a server, you can use Bloop to run things remotely. So you can have Bloop, for instance, running on your CI so that you can share hot compilers between all your test runs. It also means that you can run your compilation job on large and powerful clusters. So you can really leverage all the server infrastructure of Bloop to be able to gain seconds and minutes where it matters. For instance, on CI, if all of your compilation runs on CI are 30% faster, it's really, I think, a great improvement. So the second aspect of Bloop is that it's a command line tool that that can be used for compiling, testing, and running your project. So that's how you would use Bloop directly in your console. And it is something very simple. You have only a few commands that are well documented, that have only a few flags, that always use same defaults, and for which you can ask information to Bloop to get help and maybe better understand how it works. And we have only those 4 commands. Obviously, compile is going to compile, cleans your project, test runs the test, and console is going to open a REPL with your project in the class path and its dependencies. We tried in Bloop to be able to leverage all your shell. So you can simply use it without having to worry about being inside another program, like in SBT, for instance. Here you can just run compile, then when it's done, you can use Git. You can use shell expansion inside the command that you pass to Bloop instead of having to write new and complex tasks and remember how it works with your recurrent build tool. And you are still always in your shell to what you're used to and to what you have configured for your needs. So I think this brings more simplicity to Bloop, and this helps make for a nicer user experience than taking someone inside another program that you cannot leave easily because you don't want to get rid of your hot compilers and so on and so forth. So also something that I think brings to the user with Bloop is that you use your existing build that is already there. So you don't need to configure more things. You can just drop Bloop in and export the configuration using it. So for instance, SBT is going to generate all the Bloop configurations for you, and you don't have to actually configure Bloop yourself to work with your project. At the moment, we only support SBT and Maven, but we have more integration that we want to support, like Gradle, Bazel, and so on. And one other advantage is that once you have your project working with Bloop, you don't have to care about how you do something with one tool, how you do it with another tool. It's always the same interface that is exposed. All right. So now, why do I think that Bloop is especially exciting for Scala developers? As I've said, it's really easy to use. You don't have to care about the complex build ASL. You don't have to worry about your scope. You don't have to worry about what is a command, what is a task, what is a setting. It's really much simpler than that. It offers you a unified experience across all the build tools. You have always the same interface, no matter what build tools you are actually using behind Bloop. And for instance, you don't have to remember, oh, how did I use to only compile only my test? How do I do to run a main with some predefined arguments? How do I do to have a task that repeats itself 5 times and so on? You can do that easily with your shell to what you're used to. We also have awesome tab completion. So it's really easy to find commands in Bloop. If you don't remember something, you can see the help. You have the completion that is aware of what you're trying to find. For instance, here it finds for you the classes that you can run. And I think that also helps for the user experience. Also, Bloop is fast, as we've said. There's no startup time. You can just type Bloop and it's going to return immediately from you. You don't have to wait for it to load 5 configuration files and so on. And that also means that closing your shell is not a big deal like it would be in SBT, where you would have to wait 2 minutes for SBT to start up again, and where you would have slow compilation because all the hot compilers have been thrown away. If you close your shell in SBT, in Bloop, sorry, the state of Bloop is still there. The server has not exited, and you still have all your hot compiler, the state of project, nothing has changed. Bloop is also nice because it's very transparent. If you want to understand why it's doing something and why it's doing it the way it is doing it, you can simply open the configuration file, and I think it's pretty self-explanatory. All the values that Bloop needs are there, and you can simply look at them to see why, for instance, it doesn't have the right class path and it fails to compile something, or if you want to know what are the ScalaSphere options that are used to compile your project or your test only, and so on and so forth, you can simply look at the configuration, which is really simple and clear. So now I also want to talk about why I think that Bloop is interesting for tooling developers. As Jonathan said this morning, Bloop is an enable that made possible new projects. And let's see now how people can use Bloop to maybe do new things that were not possible before. So Bloop is exciting because I think that it opens up new possibilities. You can easily integrate it with other tools. For instance, you have Shell, which is pretty useful to integrate with our programs using terminal. So for instance, you could imagine having a command that would allow you to publish. You could do bloop test my project, and if that succeeds, just use publish to publish it. You could imagine integrating bloop using make, or of course, if you don't want to use shell, you can integrate via BSP, which Jorge and Justin are going to talk about later. Other tools can also benefit from what we've done in Bloop. For instance, you can imagine that your IDE could use Bloop to extract all the project structure from Bloop. You could imagine that SBT is simply delegating compilation to Bloop to reuse the hot compilers and so on. You can imagine that IDEs would use Bloop to have test runnings. And all of that is something that is being explored at the moment using BSP. And something else that is useful for tuning authors here is that Bloop removes duplication of efforts. So it is not interesting for us all to re-implement in every tool test discovery, how to interface with the compiler, how to make sure that incremental compilation works. I think it's much more interesting if we can just reuse all the work that has been done in Bloop, and that we use the time that we now have on our hands to build new front ends, have new ideas, get up with new models, and then get all the groundwork that is required for compilation, tests, compile, runs, and so on to Bloop, so that we can focus on new ideas. Also, Bloop being so simple, I think that it's a great platform for doing experiments. There are already people who are out there and trying Bloop and doing new stuff with it. So, for instance, we have the example of someone who just came on the Gitter chat of Bloop saying that he wanted to simulate source dependencies when he had many multiple separate repos. And so he used Bloop configuration and tried to group them together to simulate the source dependencies. And he was saying that when working on the base of his application, instead of having to republish everything from scratch, taking tens of minutes, he had the turnaround of just a few seconds. And that's exactly the kind of experimentation that I think Bloop can be useful for. So I want to present two experiments that I did myself with Bloop. First, Bloopstrap. Bloopstrap is a very simple application that I wrote to be able to generate the Bloop configuration files from a very simple and declarative build configuration. So I think nobody of you have ever seen those build definitions, but I can imagine that everybody is able to read it. It's very simple. You define the keys, the values. You cannot define new tasks and complicated stuff like that. This is very just declarative. And you use Bloopstrap then to generate the Bloop config files from there. The goal is to aim at projects that would not need a complex build definition using Maven, Gradle, or any other kind of build tool. It's something much simpler. So you write that using Holcano.json, and then you give it to Bloopstrap, which is going to generate the Bloop config files. And you can then use Bloop for your compilation, test, and run. And yeah, that's pretty much it. It's so simple, there's not much more to say about it. And so, is that really enough now that we have that? Is that enough to make it for a build tool? I guess not, but also it made me wonder if it's really always a good idea to push more code inside our builds. Should we really have thousands of lines of codes that are highly tied to our build tool? Is that something normal, or should we maybe try to reduce this dependency on our build tools and maybe come up with simpler model definitions. So that's a completely open question. And this was just an experiment that I did to see how I could make Bloop have configuration that were machine independent. Something that is missing obviously is how can we publish stuff without SVT. So this is something that could be explored, and once we have it, I think that there could be some kind of space for this minimal tool that allows you to completely get rid of SVT for everything and use very simple stuff. All right. The second experiment I did with Bloop was to implement a quick compile mode. So the goal is to simply check that a build can be fully compiled, but we don't. If we just want to see that it compiles and we have no intention of running tests or running the application, we don't really need to do a full compilation. We can do something simpler that would hopefully run faster. So what we'll do is just to get rid of method bodies. The easy solution would be to try to simply tell the compiler to stop after ref checks, but unfortunately it's not enough, because if we have multi-module build, we won't have the class files afterwards, so this downstream modules are not going to be able to be compiled, and Zinc also needs to extract some more info, so we wouldn't have incremental compilation working. So before we get started with the implementation, let's see how much we can expect to win from that experiment. So I just tried to compile the Scala library, which took 51 seconds on my machine, and when stopping after ref checks, it took 26 seconds. So it's almost a 50% improvement, which is interesting, and I think we can probably expect to get something that is less than 50%, but it shows that there is at least room for improvement. So what would be the idea? If we go beyond ref checks, we know that the trees are mostly correct. So what we can do is running just after ref checks and replace all the method bodies with triple question mark, and also get rid of all the private symbols, because we don't need those since we know that the trees are correct. And hopefully that means that we'll have much less code to compile, and so it could run faster. Moreover, the compilation could go faster. So also, if we have no intention of running those class files ever, we can just get rid of specialization to shave off a few % of compilation time too. And let's now imagine that we have the plugin. I did an implementation. It's absolutely simple. You have about 15 lines of code, I think, to do what I described. And we'll need to hook that inside Bloop. So the prototype would be simply to duplicate every project into normal and check mode, hide the check projects from the user, and then inside the check project, you just put the plugin on the ScalaSphere option, and you just change a little bit the task of Bloop to compile, so that it uses the check project when you do compile, and it uses the normal projects whenever you want to run, test, or console. So now let's see how better it fares. If you want to compile the Scala library, Scala Reflect, and Scala compiler, so those three depends, well, the Scala compiler depends on Reflect and library, so we'd have to compile the three. And if you do with normal mode, that is without shaving almost everything from the trees, it takes 67 seconds to compile on my machine. Also tried with this plugin enabled, and it went down to 53 seconds, so it's about 21% better. This is far from the 50% that we could hope to have. Yeah. Well, it's just a very quick prototype. I guess it has lots of issues. For instance, macros are never going to work because we won't have the trees that we need inside the class files, and nothing is done with the fields. But this is just a quick prototype, and I think it shows that it's really easy to hack stuff inside Bloop because of how simple its model is and how small the code base is. Okay, so what now to look forward to in Bloop, and what is taking us far from 1.0? Actually, not that much. We expect to have in Bloop 1.0 soon the Scala native support. I have been designing and implementing the Scala native build API that was introduced in the latest release while implementing it in Bloop to see how it was for integration by build tools. So I still have a prototype, and I hope to make it available very soon in Bloop. We also expect to have Scala.js support soon. This will probably come just after Scala native support gets in. And finally, we still need to add Dotty support, for which we have a prototype that was blocked by Dotty being stuck on SBT show 13. But this is something else that we plan to add for Bloop 1.0. And finally, I think that what to look forward to in Bloop, your idea could be a good idea, because Bloop is, as I said, so simple and so small. It's still something that can be understood quite easily by anyone. And so contributions are very welcome for anything in Bloop. We have a complete developer documentation available on Bloop's website. And if you want to contribute to Bloop, I think that the improvements that we make there could benefit to many, many tools out there. Right, so thank you, that's it. If you ever want to try to install Bloop using Linux, Windows, or macOS, those are the command lines that you would need. And below I have the address to Bloop's website and Bloop repository on GitHub. Have any questions?
I actually have a question. So, does Bloop provide any benefits for longer running compilations? So, if you have like a build that runs maybe 20, 30 minutes, does it provide long-term benefits or just like the startup?
I think the compilation, you mean if you have a very long running compilation for a huge project? I think it's going to be quite a great improvement. For instance, Spark is one of the biggest projects that we've tried, and it shaved about 30% of the compilation time, which in that case meant 1 minute or less. So I think you can expect improvement if for very large projects too.
Okay, thanks. Any more questions? Okay.
Thanks, Martin. I'm obviously very excited about this and the opportunities for Bloop in the future. Can you talk a little bit about using Bloop distributed across multiple machines for doing very large compilations where you're sending work out to different nodes?
This is not really something that we have actually implemented at the moment. We don't really distribute compilation across machines, but you could imagine having a Bloop server running on one machine while you're on your laptop, and you can just send the compilation jobs there.
And the sources would be sent to the remote
That's
machine?
something that you could imagine, yeah.
What's anticipated way of using it on Jenkins, for example, on CI? I mean, I would like to have a possibly clean build, correct one, and I understand that dependencies are taken by some definition created by SBT, but what performs this checkout, and is it cached, or where are the dependencies between compilations from subsequent builds?
I'm not sure I understood the question, but I was saying that the compilation is going to be faster thanks to the JIT, but that doesn't mean that Bloop would not do a clean compilation. So you could still reuse compilers that are hot, but starting from scratch without reusing class files from previous compilations, if that answers the question.
I was asking about how to insert Bloop into my build so it doesn't fetch. So which part of build will fetch dependencies?
Oh, yeah. So for instance, we're using SBT. We'll just add the SBT Bloop plugin. And when you ask it to generate the configurations, it's going to resolve all your dependencies so that they're on disk. It can simply put inside the Bloop configuration file the absolute path to the dependency.
Any more questions? Okay. Let's go. No? Okay. Thank you very much, Martin.